Oh, first. All right. Bismillah ar-Rahman ar-Rahim. Alhamdulillah. Yes. Last thing we talked about in this chapter was the oxidation number and so on. We finished with the oxidation number. Let's go now to another subject, which is called molarity. 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 What's molarity? We took this before, right? Hello?
Yes, it measures the concentration.
Yeah, but what is it? Number of what?
Number of moles of solute over volume of solution.
Liters of solution. You have to be careful with the words solution and solute. Good. That's called molarity. We represent it by what? Capital M. Capital M is equal to molarity, moles of solute divided by number of liters of solution. Okay, I want to say a certain word, concentration or concentrated. And diluted. What's the meaning of concentrated?
مركز.
مركز. How about diluted?
مخفف.
Okay. How can you make something concentrated diluted? Especially if we have solution. Add what?
Add water.
Add water. Add water to it to make it more concentration. So what's the meaning of dilution? Is adding what?
Water.
Adding,
More water.
If we have aqueous solution, by dilution we mean add water to it. We will make it diluted. Clear? Good. Now, solution A and B. Which one is the concentrated one? Is it A or B?
A.
A is concentrated. How about B?
Diluted.
Diluted. Diluted. How, and you can see it from the color and also from the molecules available. Okay, next, how can we make this goes to more diluted?
Add water.
Simple. Okay, good. Now, this is the molarity. You have to keep this in your mind, and we're going to solve problems right away. We usually represent molarity by what letter?
Capital M.
M capital.
Capital letter. All right. Also, we want, if we want to write the concentration of NaCl in solution, if we put it in parentheses, this means the molarity, this one here, the molarity of NaCl. When we put the compound or the ion inside two big brackets, this means this is also molarity. So what do I mean by this letter?
Concentration.
Concentration or molarity of what?
Iron.
Iron cation, iron 3+. Is this clear?
Yes.
Yes.
Okay, good. Next, let's solve this problem. an aqueous solution of glucose, and the first thing I want you to do, very quickly, find what's the molar mass of glucose from the periodic table. Go to the periodic table, calculate it very quickly.
Uh, 180.156.
180.2. Very good. Keep this in mind. Good. Let's solve A. Read A and then solve it. What's the molarity of 2-liter solution? 2-liter solution that contains 50 grams of glucose. What are you going to do to solve A?
Convert grams to moles.
Okay,
Yeah.
convert number of moles. Equal to what?
Mass in gram over molar mass.
Exactly. Give me answer.
0.28.
277. Good. Next. What's the molarity?
Divide by 2.
It's actually number of moles of solute, moles of solute, in this case glucose, which is 0.277, divided by what? 2 liter. Why did I divide by 2? Because it says here 2-liter solution. Clear? What's the answer?
0.139.
Big M. Good. Now, if this is the concentration in B, let's solve B. What's the volume of this solution? So this solution, we know that it is 0.139 molar. What volume of the solution that would contain 0.250 mole of glucose? If we are given the number of moles of glucose, what is the volume?
$1.80.
No, don't give me answer. What are you going to do?
Divide the mole number over the molarity.
Molarity equal to what? Moles
Over volume.
over volume, liter. Okay. What's required in this question?
The
Liter.
volume.
So this is equal to what? Moles or what? Hello?
Over molarity.
Over molarity. Molarity is given to you here, and moles is given to you here. So give me the answer.
1.9929.
1.80. Clear? Okay, last question. Same thing. The number of moles of glucose is 0.500 liter. So I want the number of moles for the same thing. The molarity
by volume.
139 molar. And I want to know number of moles. I know that molarity equal to moles over liter. So if I want moles,
multiply by liters.
equal molarity times liter.
Liters.
Give me answer.
0.069.
Exactly. How easy?
Easy.
So
Very good. Next. Dilution.
Doctor,
Yes.
the concentration or the molarity doesn't change if the number of moles and the volume change, right?
No, it has changed. We'll have this one in a while. If it's the is asking if it's the same solution. For the volume of the same solution, we took more volume or less volume for the same solution. يعني خدت كوب أو كوبين من نفس المحلول.
وحتى لو تغير عدد المولات في نفس المحلول ما تفرق المولاريتي صح؟
صح.
تمام.
Now let's have something else. If we have a solution, and this solution, I will call the molarity of this solution MC. This is the molarity. Okay, I have solution, and I know the molarity is equal to MC. I took from this solution, I took out 10 milliliter. I will call it, this 10 milliliter, I'll call it LC. Then put this 10 milliliter in another, I put the 10 here, 10, and added to it 90. What will be the volume of the new solution?
100.
100. I took 10 milliliter of this solution, alcohol solution 1, and I took 10 milliliter of solution 1. I know the concentration of solution was MC, and I put it here and added 90 millimeter of water. The total become 100 milliliter. What is the M of 2, or M, I'll call it MD? What is it equal to in this case? In order to do this, you multiply MC times the volume that you took, which is 10, and this is equal to the new concentration MD times the volume, which is 90 plus 10, which is 100, which is this one. And in this case, if I give you MC, let's say that I have MC as, okay, is this clear, by the way? And the example that I gave you. Let's assume that this was 10, as we said, and let's assume that this is 0.37, anything, okay, molar. Then I made this 100, so what's this 100?
LD.
The LD. Then what's MD?
.037.
0.037, exactly. Exactly. Is this clear?
So, doctor, the 90 is another solution that doesn't contain the solute, right?
It contains part of the solute, because we took 10 milliliter of the solute from this one. We did not take the whole thing. We took only 10 milliliter.
Okay. Okay,
and added 90 to make it more diluted. That's why we call it MD and LD. MC and LC equal to MD times LD. Clear? What's the unit? Usually, what's the unit for molarity is M. All right. What's the unit for this M? This M. What should be the unit of LC? Is it going to be liter or milliliter?
It depends on the volume that he gives you.
I mean, what's important, this unit and this unit must be the same. So if this is in liter, LD must be in what?
Liter.
Liter also.
Liter.
MLC in milliliter, then LD could be in milliliter. The most important thing, they must have what? The same
unit.
Unit.
Yeah.
Whether it's liter or milliliter. Is this clear? Good. Let's solve this problem. What volume of 12 molar HCl. So this is 12 molar. Okay, what volume of 12 milliliter molar HCl, a common laboratory stock solution, must be used to prepare? I want to prepare 250 milliliter with the concentration of 0.125 molar. So how can I do that? Read the question. Let's read the question one more time. What volume of 12 molar HCl? So I have in one, I have a solution in which the concentration is 12 molar. I want to make new solution, a common laboratory stock, must be added to use to prepare 250 milliliter. I want to prepare another solution. The volume is 250 milliliter and the concentration is 0.125 molar. How can I do that?
Using the equation we just took.
We'll take some of this and put it here and add water to it. How much, what volume should I take?
Do you want the answer?
Well, what are you going to do? Not the answer.
We multiply MD with volume D and divide by MC.
Ahsan. Yes, this is actually MD. Oh, sorry, this is LD. This is MD. This is MD. And this is LD. And what's this 12? MC.
MC.
So what's left with us? LC.
LC.
Is the volume. What's the volume then? Give me answer.
0.60.
Huh?
2.60.
2.60 milliliter. Good. Then how are you going to prepare this solution? You put the 2.6, 0, which you bring from here. And how much you add to it?
247.4.
0.4 to make the total 250, which is here. Is this clear?
Yes.
Yes.
How easy?
Very easy.
Easy.
This with what's called serial solution. Serial solution, in which we took, see, these are called, this one is called volumetric flask. Volumetric flask. This one is called pipette. We always, in the lab, you will use these words. Now, what we did in this question is something similar to this one. We bring a pipette. We know the volume of the pipette is what? In this case, it's written in. What is it? What is it?
It's 10.
10. What's the volume of this volumetric flask?
1 liter.
1 liter. What's the volume of this volumetric flask?
100.
100 milliliters.
And we do what's called serial solution. We take 10 and put it here and then dilute it with water. Then we take 10 and put it here and dilute it with water. And we take 10 and put it here and dilute it with water. And to take 10 and dilute it, because we will use the same pipette, 10, and then we'll put 10 that comes from here to here, and then add water to it until it is 100. And then to know, we want to know, calculate this concentration. Then we will take 10 from this solution and put it here. From this solution, we take 10 and put it here and then add 90 to it to make 100, and then calculate the concentration. Then we will take 10 and put it here and add 90 water to make the volume, and then find and 10 and so on and so forth. Let's do a problem similar to this one. We will do exactly the same, not the same numbers, but we will do what's called serial dilution. Let's do it this way. We have a solution in which we have stock solution, and here we have this one is 2 molar, so we know that this one is 2 molar, and we want to prepare 4 solution. Solution 1, I'll call them solution 1, 2, 3, and 4. The first one, I will prepare it by bringing, so this one, I know this one, what's the concentration of the standard solution? 2.0, that's to start. I took 10 milliliter, and make it 250. So what did I do here? I took 10 milliliter, put it here, and then what did I do?
Added 140 or 100 milli.
No, what did I add? You should add how?
240.
Exactly, you add 240 to it to make it 250. So you have 10 plus 240 to make 250. Now I want you to tell me what's the concentration of 1? What's M1? Concentration M1. I'll call every time I want to call M1. What's the concentration of 1? What
0.08.
What are you going to multiply? What? You will take
Multiply MC by LC.
Now 2.0 times what?
10 milliliter.
10 milliliter divided by
250 milliliter.
which is the new volume. Okay, give me an answer.
0.08.
0.0800 molar. Good. Are you following?
Yes.
Now,
Yes.
I took 10 milliliter of this one and put it here and add 240. 10 plus 240. What is M2? M2 will be equal to what in this case? I will take the new concentration, which is 0.0800 molar, times what?
Times
10.
10 milliliter.
10. Divide by what?
250.
250.
Give me an answer.
0.0032.
0.00. Give me 10 to the power, not like this.
Okay.
3.2 multiplied with 10 to the power minus 3.
3.2 times 10 minus 3. Good. Let's do the same with M3. What will be M3 in this case?
3.2 times 10 to the power minus 3.
M3 now. Yes, I want to calculate M3. We calculate M2, 3.2 times 10 to the power minus 3. I want M3. I took
Multiply M2 by 10, divide by 250.
Exactly. Give me an answer.
$128 times 10 to the power minus 6.
1.28 times 10 to the power minus 4, not 6. 1.28 times 10 to the power minus 4. Right, exactly. I did the same thing with 4. What will be M4 in this case?
M3 multiplied by 10 over 250.
Give me an answer.
5.12 to multiply by 10 power negative 6.
Minus 6. No. Exactly. What is this called altogether? This is called serial solution. One after the other. One after the other. And you can prepare many solutions like this. Is this clear? How easy?
Very easy.
Very so easy.
So, good. Next, let's talk about something else. As I said, when I put in a SO4, what do you read? What I read? Read what?
The concentration of this compound.
Exactly. When I put the compound in a bracket like this, I'm saying the concentration of NaSO4. And it's given to us here in this question. The concentration is 0.35 molar. Clear? Because it's given here.
And A2, Doctor, right?
No, in A2, yeah, of course. In A2 is O3, yes. It's O4, sorry. It's sodium sulfate. Clear? Next, look at the equation. In A2 is O4. When you dissolve it in water, it will give you 2 Na plus and 1 SO4 minus. Now, I want you, since you answered this one, can you tell me what is the concentration of Na plus in solution? Same solution.
0.7.
Actually, each one in the equation needs 2. That's why if the concentration of the compound is 0.35, this means the concentration of Na plus is what? 0.70. How about SO4 2 minus?
0.35.
It only needs 1.
What again?
It only needs 1.
Exactly. So it's 1 to 1. That's why 1 to 1, this means the full concentration. But
So,
with
Doctor,
2, you multiply by 2. Clear?
Doctor, does it depend on the coefficient or the number of moles?
Of course. Exactly. It depends on the number of moles, which is the coefficient, yes. All right. Let me give you some other examples. Let's assume that I have AlCl3. And let's assume that this one is 0.14, 0.11 molar. Okay, what do you read? I want to read this.
The concentration of the compound equals 0.11.
Aluminum chloride is 0.11 molar. Clear? Good. Tell me now, what's the concentration in this compound of Al3 plus?
0.11.
0.11 molar. Good. What's the concentration of Cl minus?
0.33.
Exactly. Can you tell now? Is it easy? Good. Let's solve this problem. We have what is the chloride ion concentration? That is 1.02 molar AlCl3. So what's given to you is the concentration of AlCl3. What is it? Given to you. Read the question. A, we are solving only A.
multiply
What's the question?
1.02 multiply by 3.
What is it asking about?
The concentration of chloride ion.
Only.
Chloride, yeah.
Alright, one.
What's the concentration of chloride ion?
1.02 times 3.
Give me answer.
3.06.
0.06.
Ah, 3.
Doctor, isn't it the other way around? Because
No.
I'm confused now. But isn't it the other way around?
No, one will give me 3 Cl. 1 AlCl3. This is one compound. This is aluminum chloride. But it will give you 3 chlorides. We don't write the 3 here. We multiply it by 3.
So it's 1.02.
What's the concentration? Yeah.
It's 1.02 for each atom in the compound.
Yes.
For each Al and each Cl in the compound.
Yeah. But we have 3 Cl, and that's why it's 3.06.
Yeah, okay, I understand. Thank you, Doctor.
Okay. How about the concentration of aluminum? Quickly.
1.02.
1.02 exactly. Okay. Read B and tell me what is it. Read B.
It will be twice the amount. It would be
So what's given to you? Concentration of what?
CnO2.
CaO3 twice. And what is required?
Nitrous ion.
NO3 minus. What's the answer?
Isn't it, Doctor, 0.902?
Exactly. 902 molar. We multiply this number by 2. Okay. What's the concentration of calcium 2 plus?
0.451.
Exactly. 1451. Good. Let's solve C. Read C and solve it. I will solve it here. C.
Na2CO3 in a solution in which concentration of Na is 0.124 molarity.
So Na plus is 0.124 molar. So what's
So
the
we
answer?
divide by 2.
Divide by 2.
Exactly. So concentration of Na2CO3 divide by 2. What are you going to get?
0.062.
Exactly. Clear? Any question? So, and I hope this is clear. Good. Next, gravimetric analysis. Gravimetric analysis. Gravimetric analysis is analysis related to mass, measuring mass. We call it gravimetric analysis. Gravimetric analysis. Okay? And we'll talk about the rest later on. But let me remind you before. Do you remember table 4.2 or 4.1? Was it 1 or 2? Do you remember the ions that will interact with any compound that contain? Let me show you. Did you memorize this table? Yes. Did you memorize this table? Hello?
Yes.
You need to memorize it very, very well. Very, very well. All right. Let's talk about certain ion. If you have a compound that is chloride, is it going to be soluble in water? Chloride ion.
Yes.
Yes.
Always soluble in water. But if you put certain elements will not dissolve in water. It will come out of solution. What are these ions?
Silver ion
Silver ion,
and Hg2
Mercury
gas.
was.
G and P. This means if I have a solution that contains Cl minus and I added to it silver nitrate, what will happen to the solution?
It will not.
Won't change. Yes.
Precipitate.
What will precipitate? What will happen? You will find that something coming out of solution. What's this, that thing that comes to solution?
Chloride.
Participate.
AgCl.
See.
Exactly. AgCl. Okay, is this clear? Okay. Now,
Yes.
if you know the mass of AgCl, can you tell what's the mass of chlorine in this AgCl?
Yes.
Yes.
I think it's
Yes, good. Let's solve this problem then. Okay, we have a sample, the mass of the sample. So this is the sample, and the mass of the sample is 0.8633 gram sample. Okay, read 0.8633 gram sample of an ionic compound. So we know it's ionic compound. I took it and I dissolved it in water. What is the ionic compound now? Dissolved in water.
No.
Clear? Okay.
yes.
Containing chloride ion. So there are many ions. Part of them is chloride ion. Okay. Then what did I do? I took AgNO3 and added to it. Read here. Containing chloride ion and unknown metal cation is dissolved in water and treated with AgNO3. This means I added AgNO3 to it. What will happen if I added AgNO3?
Ag will be
AgCl will participate.
positive.
Precipitate. AgCl will precipitate down. Clear? So this is AgCl. I found that the mass of AgCl is 1.5615 gram AgCl. First question is, what's the mass of chlorine in this sample, in this precipitate? I took this one and I ask you, what is the mass of chlorine? And the best way, never deal with mass, deal with mole. So if I have 1.5615 gram AgCl, how many moles is this? Go to your periodic table, find the mass of Ag. What's the mass of Ag? From periodic table.
107.
Point what?
868.
87. Good. What's the mass of chlorine?
35.453.
Add them.
$143.32.
143.
Yes.
Yeah, 143. Exactly, 143.32
32.
gram per mole. Good. Now, can you change this one into mole?
Yeah, by divide.
Divide by this number. Go ahead, give me answer.
0.011.
0.011 only? Give me more numbers.
0.01089.
Yeah, 0.89. 0.89. I like this. This is mole. This is clear. Now,
Yes.
in each one mole AgCl, how many mole chlorine?
1 mole.
0.0.
If I have 0.01089 mole AgNO3, AgCl, how many moles chlorine is there?
The same.
The same.
0.01.
0.01089 mole Cl. What's the mass?
Zero point 386.
0.386. Who else got the same answer?
Me.
Sure.
Yes.
Okay, good. So this is the mass, gram Cl. Now, what's the percentage of chlorine in the sample? Yes,
We divide 0.368 by 1.5.
1.5615 multiplied by 100.
100.
no, I want this.
Zero.
This is the
Divide by the mass of the sample.
of the sample. I want to know what's the percentage of the chlorine in the sample
44.71%.
by mass of the chlorine in the sample. So this one is 0.386 divided by 0.8633 times
44.71%.
Is this clear?
Yes.
Any question?
No?
Okay, before we go further, let's take attendance first. Okay, now the attendance is open. Anybody can actually get in and register, and then we'll go back to the discussion. All right, good. Okay. All right. Do you know how to do it this way?
Doctor,
Yes.
why we don't use 1.5615?
Because that's the mass. I want the mass in the sample. What's the percent mass in the sample? Original compound, which is this sample. And then I use the 1.5615 to calculate how much chlorine is available in this solid that comes from Ag. That's 1.5615. Then I find the mass to get the molarity. Then I change moles to moles chlorine, and then change it to gram chlorine. And this is gram chlorine. I divide by the total mass of the sample times 100. This will give you percent of chlorine in the sample.
Clear.
Good. All right. يلا شكرا شباب. اوه باقي لنا وقت، باقي 3 دقائق ستوب. والله ظنيت ان الموت 45 تنتهي 50. جود. في اسئله يا شباب؟
دكتور بس ده ما عليك امر تقدر ترجع للسيريال كونسنتريشن. في سؤال ما حليناه أبغى أسأل عنه.
شباب شيله.
ما سمعت، قطع الصوت.
قطع الصوت، ما سمعت ولا شيء يا شباب.
دكتور بسؤال سيري كونسنتريشن كان في جزئية اللي هي بي، اللي هي نطلع المولات الكل سولوشن، وهذه ما حليناها.